Hello everyone, my name is Saili Kadam. In this video, we will be talking about cross-validation. So what exactly is cross-validation? So in one of our previous videos, we discussed the train test split. So if you remember, we discussed there that the disadvantage of train test split is that the training and testing both takes place only once. So the model is only tested once. So cross-validation tries to split the data set into, or let us say, the data set is splitted multiple times so that the training and testing both takes place multiple times and the model's performance is measured multiple times. So this is how cross-validation works, or the aim of cross-validation again is to test the test the performance of the model, but the only thing is here we try to train and test the model multiple times. This is basically cross validation. There are different types of cross validations like hold out validation, k-fold cross validation, stratified k-fold cross validation, leave one out, and time series cross validation. So we will be studying each one of them in detail. So basically, train test split is used to again measure the performance of the model. Even cross validation is used to do the same. But in train test split, the model is only evaluated once. Whereas in cross validation, we try to evaluate the model, also train the model multiple times. So the first type is hold-out validation. So hold-out validation is similar as the train test split. So let us say we have the original data set. So this is the original data set. We have a training set of 80% of the data, and then we have a testing set which consists of the 20% of the data. Model will be trained on 80% of the data and it will be tested on the 20% of the data. So again, a result only depends on the one split. So this is the disadvantage of the train test split, that based on only one split, we are deciding whether the model is working well or not. So we say that it is good for large data set when we have thousands of entries or thousands of data points. In those cases, hold out validation or train test split works well because the size of the data set is vast. But limitation is that the result only depends on one split. So we only test model once and we also train the model once. So that is why it won't give us very perfect results. And we have already talked about this in our previous video. So let us start with second type, that is k-fold cross validation. So in k-fold cross validation, as we discussed the KNN algorithm. In KNN algorithm, we had a value of k, that is the number of neighbors, and result mostly dependent on the value of k. So that is a very important concept in KNN algorithm. In the same way, in cross validation, results or the working, the main concept is the value of k. Here value of k is the number of folds, and number of fold is basically the number in which we are going to divide, like how many splits we will be having in our data set. In this example, we have considered the value of k as 5. That means the data set will be divided into 5 equal parts. So here let us say we have 25 points in our data set. Then we have value of k is equals to 5. That means in every fold we will be having 5 data points. 5 data points will be present in every fold. So in first iteration, we will train on 4 folds and we will test on 1 fold. So in first iteration, the first fold is kept for testing and rest 4 are used to train. In second iteration, the second fold is kept for testing and all other are kept for training. So this process or the number of iterations are equal to the value of n. So n is basically the number of folds, and it also says that how many splits or how many iterations will be performed. So the basic working of k-fold cross-validation is divide the data set into k-folds, then perform training on k-1 folds and testing on 1 fold, and this process will be repeated k times, and at the end we average the result or average the performance of every iteration. So we take average of all these performances. So in this case we will perform how many iterations will be performed? 5 iterations will be performed. In every iteration 4 folds will be used for training and only 1 fold will be used for testing. And then so this is basic working of k-fold cross validation, and this, so the value of k, it is going to decide how many iterations will be performed. That is why we would say that this type of cross validation is good for small to medium size data set, because let us say if we have 1000 data points in a data set, so that means it is a good enough for a huge data set. So we need to perform 1000 iterations, which is not an ideal thing to do. For that reason, if we have smaller data set or we have medium data set like which have, let us say, 50 data points, in those cases we can say that k-fold cross validation works well. So this is k-fold where we train on k-1 folds and we test on 1 fold. Then we have stratified k-fold cross validation. This is similar to k-fold cross validation. Here again we have value of k is equals to 5. So we will have 5 folds in the data set, but the only difference in between k-fold cross validation and stratified k-fold cross validation is that the proportion of the classes is maintained in the folds as well. So in this example we have two classes, class 0 and class 1. So in class 0 is represented by the green dots, which is 60% in the original data set, and class 1 is only 40% in the original data set, and that is represented by the blue color. So when we will make folds, so here again we will be having 5 folds. So in those folds also we will have 60% of the data points from class 0 and only 40% of the data points from class 1. So here we can see that 4 of them belongs to class 0 and only 2 of them belongs to class 1, and that will be seen throughout all the folds. So only difference in between k-fold cross validation and stratified k-fold cross validation is that in stratified k-fold cross validation we maintain the proportion of the classes in the folds as well. That so again the basic working, the entire working of both of them are exactly the same. Only in stratified k-fold cross validation we maintain the proportion. So let us say if 90% of the data is from class A and only 10% of it belongs to class B, then in folds also 90%. In first fold 90% of the data points will be from class A and only 10% of them will be from class B. So what happens is, let us say if we are simply using k-fold cross validation. In k-fold cross validation we will simply divide the data set into 5 equal parts. We don't consider the proportion there. So it may happen that the model gets biased towards one class. So that means there is a very high chance that it will keep on predicting, or when we have testing data or when we try to test the model, it will be highly biased towards one class. So to avoid this, we have stratified k-fold cross validation where the proportion of the classes is seen in folds as well. So in all these folds we have 60% of the data sets. Out of 5, 60% will be from class 0 and only 40% will be from class B. And Again, the working is same as k-fold cross-validation, that train on k minus 1 folds and test on the remaining fold. Again, the number of iterations will be equal to the value of k, and everything will be exactly the same. Only while making the folds we need to consider the proportion of all the classes is maintained in the folds as well. This is the only difference in between k-fold. In k-fold we don't consider any proportion, we simply split the data set. And this is stratified k-fold cross validation. Then next we have leave one out cross validation. In leave one out, we don't have any folds. We don't divide the data set or we don't do anything like that. Let us say if we have the value of k is equals to 10. So out of 10, leave one out, as the name says, we are going to leave one. So if we have 10 data points, then 9 of them will be trained and only one will be tested. So again, it depends on the number of samples or number of observations. In this data set, we have number of observations as 5. So in first iteration, the first data point or the first observation is left for testing and 4 of them are tested. So one data point will be left every single time for testing. So that means the number of observations are 5. That means we are going to have 5 iterations. So this is clearly seen in this example. Here we don't have any groups. We simply take the data points as it is. We perform training on n-1 samples and testing is performed on 1 sample. And this is repeated for every data point or every observations. That means if we have 20 observations, the number of iterations will be 20. Every single time 19 will be trained and only 1 will be tested. So that means every data point will be tested and every data point will be included in training set. It has its own advantages and disadvantages. It is very good for small data set. When we have very small scale or small size data set, leave one out cross validation is good to use. Let us say if we have 500 data points, that means we are going to repeat or we are going to have 500 iterations. In every iteration, 499 will be trained and only one will be tested, which is a computationally very expensive. So this leave one out cross validation is computationally expensive. So we mostly use it for very small data set, which simply has 20 or 30 data points or number of observations are less. We prefer this for small size data sets. So this is leave one out cross validation. Then we have time series cross validation. So when we have time dependent data, when our data depends on time, so this is basically we train on past data and we try to predict the future data. Let us say what will be the temperature tomorrow or how will be the sales of my company this year based upon, or the seasonal sales. So when the time is included in the data, we say that it is a time dependent data, and here we perform training on the past data and the model is tested based upon the future data. So this is the example that we have considered. In the first iteration, we have the data available from 2010 to 2014. So all of this will be trained and we perform testing, or we will predict what will be the things in 2015. Then in second iteration, the entire data set, all the available information will be used for testing, training, and then testing will be performed. So when we have time dependent data, that is basically time series data. We call it as time series data when time is the factor involved. So mostly it is used for forecasting or any like sales. What will be the sales? What will be profit in summers? What will be in winters? So when time is involved in the result or in predicting the things, we say that it is a time dependent data. So it is used for forecasting. The simple or basic idea is that we train on past data and we predict or we test on the future data. And there is one rule we should always follow when we are working on time dependent data, that is we should never shuffle time series data. Let us say if we try to swipe any of this, so the like this data set is given that this is 2010-11. If we try to shuffle it, then the result will get affected because of it. So while working on time dependent data, we should never try to shuffle the data. So these were the types of cross validation which we used for training and testing the model. So that was all for cross validation. In the upcoming videos, we will be talking about different ML concepts, and we will continue with the supervised learning algorithms. So that's all for this video. Thank you.